Can you hear me?
Yes, ma'am.
Yes, ma'am.
Okay, Yashwant,
Yes.
can you hear me, Yashwant?
Yes,
Yashwant, talk to Tejinder ma'am.
मैम विनोद सर से तो कल बात हो चुका है।
Hmm.
मैंने स्क्रीनशॉट विनोद सर को भेज दिया तो बोले कोई बात नहीं।
Okay. Good morning, students. We'll be joining in few minutes. We'll be discussing all the questions related to part 1 and part 2 and the revision of part 1 and part 2. Is that okay to everybody? I hope it will be beneficial for you to understand what is in the part 1 and part 2 we need to study and what are the various questions that will be asked in the paper. So students, today we'll discuss about 12 people are in the waiting room. Students, kindly join on time. kindly be on time. Every time I told you 7th semester that please come on time, and some of the students are not able to join just because they need to talk to ma'am first, Tejinder ma'am. Please convey to Samarth Mittal, Vidhan Saneja, Sagar Ganavli that they must talk to Tejinder ma'am first and then can join the meeting, this lecture. So, as you all know that we are discussing part three. This we were in the part three, and now there are sessionals, and some of the students told me that they want to discuss some of the. I should discuss some of the things related to part one and part two, just because they should get an idea how the questions will be asked in the sessional. Mind it, one thing is very clear that this sessional will be of uh, 24 marks, and that is theory test will be there, as earlier we used to have a theory test. Ritvik, Abdesh Nayak, please come on time. Every time you people are late. So I'm covering all these things and will also tell you what will be the question that will be asked in your paper, in the sessional as well as in the final paper, and what kind of theory questions will come, because it will not be such kind of things, oh, what, when. It will be a kind of case studies also. So, like, you all know, we know what is, we have discussed the overview of existing hosting platforms. So I'm moving toward those slides. Everybody know that I have given the PDF files as well as the PPTs, and it is uploaded everywhere in on the ERP and on your WhatsApp groups and any other medium that we have given you. So uh, we have discussed about what is computing. We all know what is computing, the process of utilizing computer technology. Uh, Next is we'll move towards the first topic, that is autonomic computing. And I have given you the notes and I have discussed what is autonomic computing. It is a vision of computing by initiated by IBM. Anything that is related to automatically doing is concerned with autonomic computing, like knowing yourself, knowing, optimizing, configuring, healing, protecting, adapting, opening itself. Uh, like any circulatory system or respiratory system, the same way we have the system of autonomic in our body, the same way we can have autonomic system in technology also, where we can analyze, monitor, sense, and affect the elements there in the cloud computing or any other computing related to computing architecture. So these are the slides representing autonomic computing and how this autonomic computing works and what is autonomic manager. Like alerts, events, and problem analysis request interface is there. There is a SLA, policy interface, interrupts and translates into control logic. Richa Bhandari ma'am, please allow Simranjit to join the class. Next is with the autonomic computing, uh, we are discussing the various managed elements that are related to the autonomic computing. We know the elements like we have sensor, effectors, interpreters, executors, monitors, and analyzers. With that, we have grid computing, and we have discussed about grid computing. It involves a connecting geographically connecting the computers into a single network to create a virtual supercomputer. So that kind of purpose is solved by the grid of computers. You can see in the diagram here, this is the control node, and this is the grid that is formed for it. This whole computing this grid behaves like a single super virtual computer. So the grid links together computing resources like PCs. We can have a various computing resources like PCs, workstations, servers, storage elements. And by implementing our proposed internet grid, it is very easy to download multiple files very fast. So we'll discuss all these computings in with the difference also in the later stages. Why grid computing? Because has a contribution of 40% mainframes are sitting idle. So we can utilize that thing for grid. 90% of Unix servers are sitting idle. So 95% the things that are sitting idle, their energy, their efficiency, their power can be utilized for other purposes. So that is a concern. We have evolved a computing that is called grid computing. 70% of our PC servers are idle in peak hours. Next is a cluster computing. In the case of cluster computing, it is basically a group of computers that are linked together that can act a single entity. It is a kind of, we can say, kind of grid computing. Linking of two or more computers is basically taking the advantage of parallel processing power of those computers. But in case of grid computing, we are solving a problem into a single piece. We can say the form of supercomputer. The applications of cluster computing involve Google search engine. We have earthquake simulation software, image rendering, weather forecasting software. Is These are some of the examples where we have a cluster computing architecture. And benefits of cluster computing includes high processing power, cost efficiency, availability, and fault tolerance. So these are some of the benefits related to the this cluster application. Next is distributed computing. It is a form of it is also basically cloud computing is a kind of distributed. It is a solution to the problem where your RAM is too small and your data too big. So you need to have a CPU intensive processed on a single machine. In that case, you need a distributed computing because it splits a big task into smaller tasks, and that can be executed on multiple machines. So that is the concern of distributed computing. So we have discussed in detail about the distributed computing. Next is the advantages of distributed computing. Inherently distributed application, information sharing among distributed user is possible, resource sharing is possible. We have discussed all these things. Next is utility computing. Anything that is providing some kind of provision is called provisioned computing or utility computing. It is a provisioning model in which a service provider makes computing resources and infrastructure management available to the customer as needed and charges them for specific user rather than a flat rate. So that kind of computing, on-demand computing, is called utility computing. We have discussed all these things. So this is one of the diagram in which you can write if a question comes like what is the history of cloud computing. So you can easily frame, you can write this the evolving of computing from simple computing to grid computing to cluster computing to distributing computing to the cloud computing. So this is a diagram representing all these things here in the, you can see we have simple terminals and multiple distributed terminals. With the passage of time, large individual server come into existence. Then multiple distributed servers comes, and after that high density server farms, and now we are into the virtualized environment. Virtualized and software defined of everything, that is cloud enabled applications. These are the applications that are associated with every kind of computing on the right hand side, and on the left hand side are the technology for which and the computing. simple terminal access to mainframe application, multiple distributed servers that include desktop applications, large individual servers, client server applications. So these are the applications, and this includes the computing. How this computing evolved. So simple terminals to multiple distributed servers come into existence. After that, large individual servers came, and after that, multiple distributed servers, high density server farms, and virtualized and software defined everything. Now we are here on this stage where cloud enabled applications we are developing, we are using, we are storing in 2020. So this is a diagram representing from abstraction to capability aggregation. So we have first grid utility software as a service, and now this cloud computing. Anytime, anywhere, access to virtualized IT resources delivered dynamically as a service. So if you are given a question, what is right in detail about the history and evolution of cloud computing, you can write about these things: the evolution of cloud computing and how it moves from abstraction to simplification to capability aggregation. Now, this is regarding business drivers for cloud, how the business has evolved from the cloud. So, business growth increased
So
with
much.
passage of time, efficiency increased, experience increased, and assurance or safety of your data has increased. So, moving to further, because whatever we have discussed, that is another type of computing like grid computing, autonomic computing, utility computing, cluster computing. Now, the main concept, the cloud computing, and we know what is cloud computing. It provides various applications and utilities, and provides a platform to create, configure, and customize various applications online. User with cloud computing, user can access database resources via the internet from anywhere for as long as they need it without worrying about any maintenance or management of actual resources. This is the basic, we can say, base of that very cloud computing without any maintenance and management of actual resources. Where those actual resources exist, we are not towards that, but we can develop an application in the virtualized environment without having physical hardware at our premises. So it is in a simple layman language, cloud refers to network or internet, or in other words, we can say that it is something which is present at a remote location. So applications such as email, web conferencing, customer relationship management, all run on cloud computing. We know what are the two main concepts related to cloud computing. First is abstraction and other is virtualization, because abstracts a detail from of the system implementation from the user and developers, and applications run on physical systems that are not specified. And in a virtualized environment, we can put resources in a resource pool for to be used by number of people, and that number of users or number of clients or customers, and that provide a new concept called on metered basis, new concept called multi-tenancy. This is a cloud computing architecture. You can see this is a centralized hardware, physical hardware available, and from this physical hardware availability, they have created a virtualized environment in which these clients are utilizing the services of this cloud, where we have application infrastructure and storage services available. Basic concepts we have discussed. There are two models in the cloud computing: deployment model and service models. From the deployment mean, we are to how the physical deployment is possible, and in case of service model, how this cloud computing will provide the various services related to computing. In the deployment model, define the type of access to the cloud, how the cloud is located. Cloud can have any four types like public, private, hybrid, and community. So we have this is a diagram representing public, private, and hybrid community. Now, what is the difference between that? You are aware of that very difference. Like as the name implies, public means everything that is public can see and use, like email. And private is something that you own privately or your organization own privately, and it is more secure than the public cloud. It is much secure than the public cloud. Community cloud allows system and service to be accessed by group of organization. Any community can create a cloud, and this they can have access to many organization. In the case of hybrid cloud, that is mixture of two clouds, the public and private. Some of the services are public and other services may be private, and such cloud is called hybrid cloud. Service models. Service models are the reference model in which cloud computing is based. These can be categorized into three categories. We know that what are those: infrastructure as a service, platform as a service, software as a service. We know when we are dealing with the physical things or the physical resources like physical machines and storage machines, those are called infrastructure as a service. Usually build entity usually build based on usage. Multi-tenant virtualized environment is provided, can be coupled with managed service for operating system and application support. See, these are some of the examples of that are providing infrastructure as a service: AT&T, Blizzard, GoGrid, open source, entity communication. Now, next is platform as a service. PaaS provides a runtime environment for application development and deployment, and typically applications will be developed with a particular platform in mind. Multi-tenant environment, highly scalable multi-tier architecture is possible in case of platform as a service. The basic concept of platform as a service is to provide a platform for developing your application. Rather than you develop on your side, they give you the platform for developing your application. They will provide you the infrastructure, and then they will provide you all the related software, licensed software that can be used for your application development. You need not to buy all these things, just you have a login account with that particular service provider, and you have to pay the fee for those services as wherever required. Next is, these are some of the examples like Amazon Web Services, Azure, Rackspace, Joint, that are providing the platform as a service. Now, next is software as a service. So, software as a service is when you provide service provider provide software delivery methodologies. Uh, Service is called software as well. Like we are getting emails and we are checking our emails, sending emails. That kind of service software we are provided by the cloud computing organization, and that is called software as a service. Usually built based on usage, multi-tenant environment, highly scalable architecture. Salesforce.com, Postiny, Facebook, like we are using Facebook. This is software as a service. These are the things that are in comes under the heading of GTalk, Google applications. All are part of the software as a service. So, question comes: do you use a cloud? Yes, everybody nowadays using the cloud, just because uh, if we are using Kindle, Google Play, iBooks, YouTube, Netflix, all these things are on the cloud. Instagram, everything is on the Twitter, everything is on the cloud. So what are the advantages? Lower computer cost, improved performance, reduce software cost, instant software dates, improved document format capability, unlimited storage capacity is provided by cloud, increased data reliability is there in cloud, universal document access is possible. You can save the things and you can have access on the other location, having a login and a password only. Easier group collaboration, device independence is possible. What are the disadvantage? You need to have a constant internet connection, does not work well with the low speed connections, feature might be limited. Sometimes it can be slow, stored data can be lost. Because why storage is a concern? Because it is not in your hand. Whenever you are saving your data on the cloud or saving your application on the cloud, or if you are developing anything on the cloud, there will be a kind of um, um, fear in your mind that my data can be lost or can be used or by some uh, uh, the party, a third party, which I am not confident on. So such kind of concept is possible. Store data might not be secure on if you are placing on the cloud. Like we have SkyDrive, Amazon Cloud Drive, the Dropbox. These are some of the examples related to the cloud storage. So basic, we have a cluster computing, grid computing, and cloud computing. So the basic ad advantages, the difference, and we have discussed the advantages and all these things. Now the difference between these things like cluster computing, grid computing, and cloud computing. So first is the first this point is related to the characteristics. So cluster computing is tightly coupled system, while grid computing is loosely coupled system. And on the other hand, cloud computing is dynamic computing infrastructure. That is why it is called dynamic computing infrastructure, just because we can add resources and can delete resources. And that concept is called scalability. We know that concept. So single system image is possible in cluster computing, diversity and dynamism is possible in grid computing, and IT service centric approach is there in the cloud computing. So in case of cluster computing, centralized job management and scheduling system. In case of distributed computing, this grid computing, everything is distributed job management and scheduling. And in case of this cloud computing, basically it is a self-service based usage model and minimal or self-managed platform for consumption of based billing. Next is in cluster computing, a bunch of similar computers are hooked locally. We know that they are hooked locally in the same physical location, directly connected with very high speed connection to operate as a single computer. But in case of grid, the computers do not have to be in the same physical location and can be operated independently as far as other computers are concerned. In cloud computing, the computers need to be in the same physical location, but not in every case. The cluster computer all have a
Hello?
hardware and operating system. Rima, is there any issue? The computers that are part of grid can run different operating system and have different hardware. That is not possible in case of cluster computing because hardware and the operating system are similar. But in case of this, we have different computers and different hardware system interacting with each other. Memory, storage devices, and network communications are managed by the operating system or the basic physical cloud units. The whole system behaves like a single system in case of cloud computing, and this every node is autonomous in case of cloud grid computing. In case of cloud computing, it is an independent entity. It is considered as an independent entity. The computers in the cluster computing are normally contained in single location or a complex, but in case of grid, this grid may be extended to LAN, MAN, or WAN. Clouds are mainly distributed over WAN. Earlier it was on MAN, but now it are clouds may be possible on MAN as well as WAN. More than two computers are connected to solve a problem. If you are connecting two computers to solve a particular problem, you may say that you are running a cluster. Large project divided amongst multiple computers to make use of the resources. Then you can say that you are working on a grid computing. It is just the opposite. It allows the multiple smaller applications to run at the same time in case of cloud computing. So these are the some of the application areas of cluster computing, like educational resources, commercial sectors for industrial promotion, medical research, and predictive modeling, simulation, engineering design, and automation, medical, military, and basic research, visualization are some of the application areas for grid computing. Banking, insurance, weather forecasting, space exploration, software as a service, infrastructure as a service, and PaaS are the examples of cloud computing. Next is we have scalability is 100 seconds. In the case of this grid, 1,000 seconds, and size or scalability in case of cloud is 100 seconds, 2,000 seconds, single ownership, multiple ownership. Cloud again single ownership because we have a single service provider. It has dedicated high end with low latency and high bandwidth internet connection. Mostly internet with high latency and low bandwidth is possible in case of grid, and in case of dedicated high end and uh, good internet connection is required in case of cloud computing. So traditional login password based approach can be used in this cluster computing. Public private key paired based authentication mechanism is possible in case of grid computing. In case of this cloud computing, each user application provides with the virtual machine, high security, privacy is guaranteed and provided, and support for setting up per file access control list is possible in case of cloud computing. So membership service discovery is possible in the case of this cluster computing. Centralized indexing and decentralized info service discovery is possible, and membership service discovery is possible in case of cloud computing. Now, uh, limited service negotiation in case of cloud computing. Yes, SLA is possible in grid computing, and SLA based service negotiation is possible in case of cloud computing. Now, my question to the class is, what is SLA? Nobody asked me what is SLA, ma'am. What are SLAs? Anybody? What are SLAs? Service level agreement. Uh, Abdesh, you, Abdesh is telling me what are these service level agreements, Richa, Rohit? Nobody knows more than me.
Three types of
These are the agreements between the service provider and the customer or the client, on which both there will be a kind of negotiation that they will provide these services, and they signed a contract, and that contract is called an agreement on the providing various services to the client. So service level agreement depends on the service provider as well as on the customer or the organization that is taking the services. That is the basic concept, and I have discussed that concept in detail in the another PPT. Now next is we are moving further on the new topic. Now questions related to this topic. Uh, the questions can be like, what is the difference between the autonomy computing and cloud computing? How you and differentiate between them? I have given you that difference also, and there may be a question related to the uh, cloud computing service models. You need to discuss all the service model, deployment model, and the other service models or both the models. What is the base of cloud computing? Base of the computing is based on two concepts. You need to describe those two concepts. That one is called abstraction, and other is called other concept is called
Virtualization.
virtualization. Now, next is that they may be asked you the questions related to the challenges and obstacles in cloud computing. So you should know what are the various challenges and obstacles. Can anybody tell me what are the various challenges and obstacles you feel that there are in cloud computing? any challenge and obstacle you can quote. This might be a challenge in cloud computing. I feel like uh, I can discuss one of the concept. I will discuss all the concept, but uh, for your hint, the concept is network bottlenecks may be possible in cloud computing. So this will also be a challenge. Any other challenge that cloud computing is facing? Tanvi, Sheesh, Rohit.
मैम सॉरी, ये हो सकता है पैसा बहुत लग रहा है, और दूसरी बात है कि सर्वर भी ऑन करके रखना पड़ता है 24 घंटे।
Paisa economies, we are into economics, like we are saving the money, we are getting revenue if we are investing the money. See, earlier, why this cloud computing coming is coming nowadays and is very much popular among the companies, big companies like IBM, Azure, Microsoft, and Amazon, just because earlier they were doing simple operations like uh, any kind of web development, any kind of development of software. But they realizes that their infrastructure they have deployed, they that infrastructure is not being fully utilized by the employees who are developing various projects. So for that they come into the concept called cloud computing, in which they are providing the infrastructure, they are providing the software, they are providing the platform, so that their their infrastructure can be fully utilized with the demand of the customers, so that they can generate revenue. पैसे की तो बात हो रही है ना, क्लाउड कंप्यूटिंग में सब कंपनीज क्यों आ रही है, IBM में आ गई, गूगल इज मूविंग टुवर्ड्स क्लाउड, एवरी small companies now moving towards, just because towards cloud, just because they want to generate revenue from that particular physical hardware. So the challenge is that should be in the cloud computing is the compliance. So the policies uh, uh, for laws and policies depends on the geographical areas. Like we are living in India, some people are living in America, some are using, and everybody is using the AWS. Suppose every country is using the AWS. So the challenge will be the compliance, because policies and rules will differ from one country to another country because of the geographical area. So that will be an issue, or we can say a challenge. Compliance will be a challenge. So like service level agreements will be a challenge, because it will be different in case of India. It may be possible that it will be different for in case of South Africa or any other country, just because of the economy and all these things. Next is data privacy. Data privacy is a challenge in case of cloud computing. So because we need to install all the encryption, VLANs, firewalls for the sensitive data. Next is network bottlenecks will be kind of high in case of cloud computing. That can be that must be solved. Next is security issues will be there, like trust mechanism, uh, how we can have a trust mechanism between the service provider as well as towards the client. That is also obstacle, or we can say the challenge. I hope now everybody is clear with the challenges and obstacles that are there in the cloud. In,
मैम एक डाउट है।
Niklesh, is there any who is asking? Rohit? हाँ जी,
यस मैम।
हाँ जी जी बताइए।
मैम जैसे हम EC2 इंस्टेंस अगर यूज कर रहे हैं क्लाउड
हम्म।
कंप्यूटिंग के लिए, तो उसमें जैसे कि हमें पूरा कॉन्फ़िगरेशन देना पड़ता है कि हमें कितनी मेमोरीज की रिक्वायरमेंट है, और एट द सेम टाइम अगर हम रन कर रहे हैं और हमने कम मेमोरी दे रखी है, तो क्या इसे भी हम चैलेंज की तरह ले सकते हैं, क्योंकि ये
No,
AWS की तरह मतलब
cannot
फ्यूचर
take.
टेलिंग नहीं ना करता?
I'll tell you one thing. Like we are talking about EC2 service, like Elastic Cloud Compute, and it is provided by AWS, Amazon Web Services. If I am taking some service like EC2 मैंने एक लिया और उसमें कुछ memory है, and I now need more memory for that, and this is possible in case of cloud computing. There is one concept called scalability, in which we can increase the resource according to our choice, and we have to pay for that only. We can scale up and we can scale down the various resources required for developing any kind of application. So this will not be a challenge. The challenge is with not with the customers, the challenge is with the service providers. They have a challenge of data privacy, to keep the data secure. They have a challenge of compliance because they are providing services to many countries, to many organizations. So they may be facing some kind of compliance challenge or service level agreement challenge or network bottlenecks. There may be things like if you are sitting in the local area network and you are asking me for a file, and if I send it through some wide area network or anything, that will be a foolishness, because if we are working on a local area network, I'll send the file through local area network. Why should I send to a wide area network? If everybody in an organization is doing through a wide area network, that will create a kind of bottleneck, network bottleneck.
Okay, ma'am.
I
Thank you,
hope
ma'am.
that is clear to everybody and Jodit also.
Yes, ma'am.
So these are some of the security is a challenge for the organization as well as to the service provider. Like if I am the client, मुझे तो ये tension रहेगी ना whether my data is secure or not, just because it is not in my hand and that data is not at rest, that data is in transit. वो मेरे साइट पे मैं उसको change करी and every time storing on the cloud. So that will be a kind of challenge for me. मैं कर तो रही हूँ, I am developing my application, इतना सारा मेरा budget है, I have a big company and so many employees are there and we all are working on Amazon Web Service. तो कल को डाटा की क्या इशू होगा, मेरा में वो everything can be retrieved, there will be a kind of data loss. So if we are facing some challenge, that will be more faced by the organization that are providing the services. बिकॉज उनको भी तो चैलेंज है ना, उन्होंने हर बंदे का, हर ऑर्गेनाइजेशन, दे आर कीपिंग द डाटा एज वेल एज दे आर प्रोवाइडिंग द सर्विसेज एंड दे आर प्रोवाइडिंग द images, cloud computing, image mean computing devices. So that will be challenge more towards the service provider, though it may be towards the uh, customer or the client challenge. Next is we were discussing the challenges and the obstacle. Now we'll move towards the next part, and let me see if that is available here. Next is we were discussing the various other things we need to discuss is the NIST model, and I have discussed the NIST model. And with that, um, everybody know what is National Institute of Standards and Technology. This model was given on for on-demand network access to a shared pool of configurable computer resources like network, server, storage, application. And this model was given by the US Army forces. This model first जो क्लाउड कंप्यूटिंग यूज की थी वो यूएस आर्मी ने यूज की थी. दैट मॉडल वाज कॉल्ड नेशनल इंस्टीट्यूट ऑफ स्टैंडर्ड्स एंड टेक्नोलॉजी मॉडल फॉर प्रोवाइडिंग द वेरियस resources, configurable resources like network, server, storage, applications in a shared pool. That model is called NIST model, and we have discussed about scalability and elasticity. I'll discuss again what is elasticity because some of the students were not present in the starting lectures. Cloud elasticity is a system's ability to manage available resources according to the current workload requirements dynamically. So to manage that current workload requirement dynamically, we can say the system is, if it is managing those things, that system is elastic. Elasticity is a vital feature of cloud infrastructure. It comes in handy and when the system is expected to experience sudden spikes of user activity. As a result, a drastic increase in workload demand is there, and that service provider is able to provide that drastic spikes that is originating, providing resources is called elasticity. We can give an example of elasticity like streaming services, like we have a this, we all know this Netflix is on cloud computing. So whenever they have given an example of Mindhunter streaming season, that whenever notification trigger that this significant number of users get on the service, that Mindhunter जो है वो series आने लगी है, to watch or upload the episode, source wise इतने activity spike बढ़ गया. Like We have Amazon Prime Day event with many special offers, sell-offs, promotion, discounts. It attracts people or customers, number of customers. So that means a spike is increased, number of resources required is more. And if we feel like more resources are required as we are into that organization, e-commerce organization like Amazon, so if we are able to flexibly increase the number of resources without any problem, that concept is called elasticity. I hope everybody is now know what is elasticity. Now, what is scalability? It is a quite common term and related with this like scalability. Cloud scalability is the ability of the system infrastructure to handle growing workload requirement while retaining a consistent performance adequately. And unlike cloud elasticity, which is more of makeshift resource allocation, basically elasticity is a makeshift arrangement of resources. Scalability is a part of infrastructure design. You always remember one thing: this elasticity and scalability are two different things. Whereas elasticity is some kind of makeshift arrangement, while scalability is growing the infrastructure design. So that is a basic difference. Scalability is one of the preeminent features of cloud computing. Uh, in the past, system scalability relied on companies' hardware and thus was fairly limited in resources. So automatic scaling opened up numerous possibilities for the implementation of big data machine learning models and data analytics to the fore. So I hope everybody now knows the difference between the scalability and elasticity. Usually question comes in paper, what is the difference between scalability and elasticity? Or there may be a question that discuss in detail about the scalability with an example, or there may be a question discuss in detail about the elasticity with reference to cloud computing infrastructure. So you should be able to write what is scalability, what is elasticity, what are the difference between them, and you can quote such example like I have discussed with you, Netflix and this e-commerce application like Amazon. So this is the you can quote. In case of scalability, we have increasing the infrastructure, we are scaling up the infrastructure, we are scaling down the infrastructure. But I'm again repeating, in case of elasticity, we are only making makeshift arrangement of the present infrastructure. That is not scaling up. Overall, cloud scalability covers expected and predictable workload demands and also handles rapid and unpredictable changes in the scale of operation. The pay as you go expand pricing model make possible the preparation of the infrastructure and spending budget in the long term without too much strain. जैसे रोहित ने पूछा था कि I want to increase the memory, he can increase the memory because this is called, that is a concept of, we can say, elasticity, a kind of makeshift arrangement on the client side. But if we are increasing the infrastructure, the service provider is increasing the infrastructure, scaling up the infrastructure, that is concept is called scale up. We have a vertical scale up, horizontal scale up, and diagonal scalability. We have discussed these things in detail in the previous lecture. I hope everybody can now study these things according to their um, time. We will not discuss, go into the detail of the scalability more. Now, next is billing and metering services. And in billing and metering services, we have different billing and metering service for different so, infrastructure as a service, platform as a service, and software as a service. So here figure shows an example how we can build the things. Like you can see in the example here, there is one transaction with the name T1, T1234. How this transaction is moving from the HTTP server to request controller to the various further services like hamburger grill service, lettuce service, onion service. These are different names given in the that very organization. And you can see this thing, this is the external environment, this is the internal cloud environment. So this transaction that is happening and where it is moving and how much services it is utilizing is, we can calculate the billing and metering. In figure shows an example of hamburger builder transaction that includes the different SOA services. So SOA stand for service oriented architecture services and uses a transaction ID that is 1234. Agents are deployed on all the nodes of the nodes. to capture the transaction data for each transaction. So here agents are deployed and they calculate the data on each node. Each node they are calculating the data. Here T123 is the transaction ID that identifies the transaction. Each service type the elapsed CPU time. So it will calculate the elapsed CPU time at every node and then calculate its bill. So that way the bill is calculated for a particular service. So in case of infrastructure as a service, where we are only providing the infrastructure, we are only providing some EC2 machines. In that case, we are providing servers per hour service, serving on an on-demand model, reserved server for better planning, high and lower compute resources, volume-based metering is provided, prepaid and reserved infrastructure resources, and cluster server resources are possible in case of this infrastructure and billing and metering services. Next is this is an example of AWS bill. Some of the people may not have seen earlier. This is AWS bill. You can see here there. You can see here they have charged for Amazon EC2 running Linux machine for per small instance, and for 3 hours they have charged $0.26. You can see here, and here you can see also they have charged for 100 hours 5.64. So in this way, Amazon EC2 EBS. EBS stands for electric block storage. And this is the charges. These are the charges for those EBS services: 0.30, 0.05, 0.01. You can see on the screen. In this way, they have calculated the bill. Like जैसे हमारे घर में bill आता है, one time fees during billing cycle 0.00, any taxes, and this is a total bill that is $6.32. That so whenever you are making an account on AWS, I told you earlier also that you should see first with the various services, because some of the services are free and some of the services are paid. Even if you are not using that service, if you have availed that service, you have to pay the rent for that particular EC2 service. So they have categorized the services like free services, microservices, and macro services. Before using any kind of service on those websites, where they are providing the infrastructure, they are providing the platform or the software for developing your applications. You must see the documentation, study the documentation before any availing any kind of service. So this is one of the bills generated in the infrastructure as a service. Next is platform as service and billing and meeting for platform. Platform as service, billing and meeting are determined by actual usage. So as platform differ in aggregate and instance level usage measures, actual usage billing enables PaaS provider to run application code for multiple tenants across the same set of hardware depending on the granularity of usage monitoring. So whenever you are developing an application, you are using the platform as a service. For example, you should be using you are using the network bandwidth, you are using the CPU utilization is the concern, disk usage per transaction. So the calculation of bill will be based on CPU utilization, network bandwidth, disk utilization. These things matters in case of platform as a service. CPU time per hour, stored data, availability of the data, monthly service charge you have opted for, and such things calculate your bill on the platform as a service. Next is the SaaS. So SaaS is software as a service, that is basically an application fixed monthly basis. In some cases, it depends on the amount of data and number of seats. The billing and pricing are optimized. It depends on service provider to service provider, and they are totally optimized. Number of user is determined by the number of users in the organization allowed to access the SaaS application. If I am running an organization and only 3% are using a particular SaaS application, those 3% contribute to the particular kind of bill for that SaaS application. So it also depends how many users are using the service for that particular SaaS application. There are certain discounts available if you are taking the services in bulk, or you are taking the service for a year or 2 years or 3 years. Depends on the type of we can say service, and how you are taking whether you are taking prepaid kind of service or you want a postpaid kind of service. Both are available. Next is virtualization. I told you that virtualization is basically a concept related to creating a virtual environment or virtual version of something such as hardware, platform, operating system, storage devices. And this concept is not new because we are into a concept, or earlier we are into a concept called we were into a concept called multi-programming, which we are using virtual memory and CPU sharing. So from this multi-programming concept, the from this multi-programming comes another concept that is called virtualization. So we can have different types of virtualization: network virtualization, storage virtualization, server virtualization, data virtualization, application virtualization. And I have discussed all these virtualization in detail. How we can virtualize a network, how can we virtualize the storage, how can we virtualize the server, how can we virtualize the data, and what does these mean, and how we can virtualize the applications in the virtualized environment. With the virtualization architecture, uh, you can see this is the physical hardware, like my hardware, like my machine. For creating any virtualized environment, we need a hypervisor or virtual machine manager. This hypervisor is called virtual machine manager. It behaves like a it it provides the facility to run multiple operating system on a single machine. So whenever you can run multiple operating system with the use of some kind of virtual machine manager or hypervisor, you are creating a virtualized environment in the on that very machine. Always remember one thing: while creating this virtualization concept, you know, must keep in mind some of the things that are not discussed in this slides here. You should have a very high configuration of your physical device, to create a virtualized uh, environment or virtualized machine. Like I cannot create a virtualized machine on my simple computer, just because it will not handle the number of operating system. It may handle a single operating system, but it will not handle more than 3 or 4 operating system. We do usually do double booting, or we can say dual booting concept, and that concept is also called virtualization. But for running 3 to 4 or more than that guest operating system on a single machine, you need to have a very high configuration to create a virtualized environment. So operating system assumes complete control of the underlying hardware. Virtualization architecture provides illusion through a hypervisor, virtual machine manager. And hypervisor, virtual machine manager, is a software layer. It is not any kind of hardware layer. Always remember, this hypervisor is not a software layer. It allows multiple guest operating system to run simultaneously on a single physical host, and provide hardware abstraction to the running guest operating system, and efficiently multiplexes underlying hardware resources. So moving ahead, now we'll discuss some of the quiz questions related to this cloud computing. So here these are. Kindly answer these questions. Can you see this poll? Kindly answer these questions. Which of the following is most important area of concern in cloud computing? Security, storage, scalability, or all of the above. Next is, which of the following architectural standards working with cloud computing industry? Service-oriented architecture, standardized web services, or web application frameworks. Next is, point out the correct statement. Service level agreement is a small aspect of cloud computing. Cloud computing does not have impact on software licensing. Cloud computing presents a new opportunity to users and developers, or all the mentioned. Next is dash is pay as you go model matches resources to need on the ongoing basis. Whether it's utility, elasticity, or low barrier to entry, or all of the mentioned. Shivam, you may not be able to see this poll just because you have joined recently. Kindly answer these questions. Time is running. Only 40 seconds more. Still, students have not answered these questions. I am ending poll in 10 seconds. Ending this poll now. So first question is, which of the following is most important areas of concern in cloud computing? That is, security is the most important area that is of concern. Next is, which of the following architectural standard is working with the cloud computing industry? That architectural standard is service oriented architecture. Next is, point out the correct statements. Service level agreements is small aspect of cloud computing. This is not a correct statement, SLA. Cloud computing does not have impact on software licensing. This is not a correct statement. Next is, cloud computing presents new opportunities to users and developers. This is true. So all of the mentioned is not correct. Next is, dash is pay as you go model matches resource to need on ongoing basis. This is concept is called utility concept. So these are the answer to all these questions. There is another quiz related to it, cloud computing. Answer these questions. First is dash blurs the difference between a small deployment and a large one because scale becomes tied only to demand. So whether it's leading, pooling, virtualization, or all of the mentioned. Next is which of the following subject area deals with pay as you go usage model. Next is security methods such as private encryption, VLAN, firewalls come under dash subject area. Next is which of the following is specified parameter of SLE? Response time, responsibilities of each party, warranties, or all of the mentioned. Kindly answer these questions, and most of the students are answering incorrectly some of the questions. Kindly read the question first thoroughly and then answer. I'm repeating, dash blurs the difference between a small deployment and large one because scale becomes tied only to demand. Which of the following subject area deal with pay as you go usage model, whether it's accounting management, compliance, data privacy, or all of the mentioned. Next is security methods such as private encryption, VLANs, and firewalls come under dash subject area. Next is which of the following is specified parameter of SLA? Is response time, responsibilities of each party, warranties, or all of the mentioned. Kindly answer these questions. Only 10 students have answered these questions till now. I am ending this poll. This poll will be will be counted for your response in the future. Kindly be attentive and answer these questions. I am ending this poll in 40 seconds. I'm ending this poll. So, first question is pooling blurs the difference between a small deployment and a large one because scale becomes tied only to demand. Next is which of the following subject area deals with the pay as you go usage model, that is the accounting management. And third is security methods such as private encryption, VLANs, and firewall come under dash subject area, that is data privacy. Next is which of the following is specified parameter of SLA, and that is response time. Which of the following is one of the properties that differentiates cloud computing? So that property is composability. Moving further, next we were discussing this virtualization architecture. So you can see on the screen here that physical versus virtualization architecture. This is a simple architecture, physical architecture, and here you can see the virtualized architecture. And we have discussed these things in detail when we discussed the virtualization concepts in the previous lectures. So I think everybody is clear with the idea that this has a single operating system, and this machine has multiple operating system. Hardware plus software are tightly coupled in case of a physical machine. Application crashes affects all, but in this case, if an application crashes, it will affect a single machine of that particular concern. Resource underutilization safely multiplex resources across virtual machines. So next is types of virtualization, process view of machine, system view of machine. So in case of process view of machine, environment to support multiple processes, sharing resources, hardware characteristic define system view. In case of system view of a virtual machine, memory, user level instruction, system calls for operating system functions. So operating system interface to hardware defines view of processes. So example of process virtual machine is Java virtual machine, .NET emulators. But system virtual machines, like whenever we are creating virtualized systems, virtual machines, we use Zen, KVM, VMware, VirtualBox, and these are called system view of virtual machines. Next is benefits of using virtual machines. Instant provisioning is possible, fast scalability, live migration is possible. You can migrate a particular virtual machine from one host to another. Like if as this Rohit is telling me that he has been provided a virtual machine by some of the organization where he is working, suppose. So if he wants to move that or migrate that particular machine to another host in the same organization, so that kind of migration is live migration is possible, but that is not possible in case if he wants to physically move that machine to other location. So that live migration is possible in case of virtual machines. Load balancing and consolidation in data center is possible using virtual machines. Low downtime for maintenance, and virtual hardly there is any kind of downtime. Virtual hardware supports legacy operating system efficiency. Legacy operating systems are the those that are the uh, traditional system, we guess. And security and fault isolation is possible in case of virtual machine. So you can see here this is VM migration. Suppose this I have discussed in detail about this thing. Uh, this A machine has two virtual machines, and this B has only one machine. So live migration is possible in case of virtual machines. In this way, they can move the machine from one system to another. So suppose it has three virtual machines, this has two virtual machines. One virtual machine can be shifted here, live migration can be done, and that concept is called load balancing for better response time. So this concept is called moving machine to a particular machine, like C machine, reducing the number of physical machine requirement. Like we are using three machines, three physical machines, and on these three physical machines, we have three virtual machines. So consolidation can be possible. You can have one physical machine and three virtual machine on it like this, and that concept is called consolidation. That is also possible in case of virtualized environment, and that is the advantage of virtualization. Next is importance of virtualization in cloud computing. Cloud can exist without virtualization. Yes, possibly cloud can exist. but this will not form any kind of, this will not be a efficient utilization of the resources. For cloud makes notion of pay for what you use, infinite availability, use as much as you want. Cloud works on the concept of pay for what you use. So for such kind of concept, we need virtualization. Pay for what you use. If to provide a pool of resources and giving the user a facility to use anything and pay for that, need to have a virtualized concept. This efficiency is readily available in virtualized environments and machines, which efficiency pay for what you use. Requirement for virtualizability. So these are the some of the things we have discussed, how people merged and how virtualization come into existence. We have discussed about the privileges, like privilege ring. This privilege rings we have discussed that u zero has a highest privilege and 3 has a least privilege. This is a kernel level instruction. These are the unused instruction, and these are the application oriented instructions. Virtual machine implementation techniques like binary translation, para-virtualization, hardware supported virtualization. You need to study these things, but not in very much detail. Only you should know the terminology for that, like what is binary virtualization, need to use in VMware, binary image of operating system is manipulated at the runtime. What is para-virtualization, need to use in Xen. It makes operating system aware of the underlying virtualization environment, and in this case, in case of para virtualization, operating system code can be manipulated. So that is a para virtualized environment and hardware supported virtualization concept. Next is Zen. Then is a VM virtual machine manager. So with that we have Zen domain, CPU sharing, hypercall. What are hypercalls? What are memory sharing? There may be question related to what is Zen and what are the various components of Zen. So you should know these components, or these are used. And I have discussed in detail about the CPU sharing concept in case of Zen. This is this description of Zen. How virtual machines can be shared, or we can CPU can be shared in the virtual machines. You can see here in the diagram. Next is Zen hypercall discussion. This how these hypercalls can be there in the case of Zen. Memory sharing concept like hypervisor, Zen, kernel and application levels. Input output sharing. Next is Zen and input output split device driver. You need to study this thing, but it will not be asked in your paper. Only you should know that first we have a hardware layer, then a Zen is working like virtual machine manager, and after there is a guest operating system. So you can see domain U guest operating system, domain zero guest. For U and zero, what does this zero and U mean? Anybody in the class? What does this zero and U mean? I've discussed in these things in detail in those lectures. Uh, can anybody tell me what does this zero and U mean? कोई क्लास में है? आकाश, संचय, शीश, Tanveer Kaur,
Yes, ma'am.
Vaibhav, what does this zero and U mean in this slide? These were the privileged instruction, privileged and unprivileged instructions. याद आया कुछ? डोमेन जीरो, डोमेन यू, क्या हो गया क्लास को? अब वापस मैं जाऊं वहां पे बताने के लिए, कहाँ पे थी स्लाइड? These are the two types of instruction, privileged and unprivileged instructions, that are called zero and U instructions. Chalo, anyhow, you need to study this zero and U instruction, that is privileged and unprivileged instruction. Shivam, is that clear to you? Shivam Kapoor.
Yes, ma'am. Yes, ma'am. Clear.
So these were things related to Zen, and a question in paper can come like, what is Zen? What are the various components in Zen? You need to define those components. Like मैं दोबारा से बता रही हूँ कैसे क्वेश्चन आते हैं और आपको कैसे आंसर करने हैं. What is Zen? Zen है क्या? Zen is virtual machine manager, and these are the components. Zen domain, CPU sharing is possible in Zen. What are hypercores, memory sharing, input output sharing, Zen split driver techniques, and input output ring. We have discussed this input output ring, like ring 1, ring 0, 1, 2, 3. This is a kernel level ring. These are basically instructions that are privileged and unprivileged under unprivileged instructions. So this was all about virtualization, and moving further. Now we'll discuss the further thing. This is lecture 4. So next is a brief history of compute virtualization. What is this compute virtualization? I discussed. Next is VMM or hypervisors. We know this virtual machine manager. We have discussed compute virtualization types. Like we have discussed what are the various compute virtualization types. We should know what is host operating system, what is the guest operating system. So now everybody is clear that the machine you are running, like you are running any machine, you are have any physical machine. That physical machine is called host machine, and on that physical machine you are installing virtual machine manager or any kind of hypervisor. On that you are installing any operating system. That operating system will be called as guest operating system. So that is the difference between the guest operating system. And after running that guest operating system, you are running any application on that guest operating system, and that machine will be called as guest machine. So that is a concept. Functions of hypervisor. Hypervisors provide identity, capture, response to privileged CPU instruction, or protect instructions sent by virtual machine. Schedule virtual machine queues. These are the duties of hypervisor. Everybody should know that physical machine के ऊपर hypervisor आता है. On above the second layer on the physical layer is the hypervisor, and it provides identify, capture, respond to privileged CPU instructions, schedule VM queues, and return physical hardware processing result to the related virtual machines. Types of hypervisor, we know there are two types. One is called type 1 hypervisor, another one is called type 2 hypervisor. Type 1 is called bare metal machine hypervisor. This type of hypervisor has direct access to the hardware resources and does not need to access the host operating system. The hypervisor can be seen as a customized host operating system which merely function as VMM and does not run other applications. So these are the examples of type 1 hypervisor: VMware ESX server, Citrix Zen server. This is used by Citrix Zen server and Fusion Compute. These are the two hypervisors that are used by the Hawaii cloud computing architecture. Next is advantages and disadvantages of those type 1 hypervisors. Advantage of type 1 is that virtual machines can run different types of guest operating system and application independent of the host operating system. And disadvantage is that the kernel of the virtualization layer is hard to develop in case of type 1 hypervisor. In case of type 2 hypervisor, and that hypervisor is called hosted hypervisor. A question may come in exam: what is hosted hypervisor? Write in detail about the hosted hypervisor. What are the various examples of hosted hypervisor, and what are the advantages and disadvantages of hosted hypervisor? So hosted hypervisor is nothing but a type 2 hypervisor that is not a bare metal machine. I'll show you an example here in the diagram here, if it is possible. We have discussed, it is not here or it is maybe in the previous slide, type 1 and type 2 hypervisor. So type 2 is hosted hypervisor. Always remember this thing. And in physical resources are managed by the host operating system. VMM provides virtualization services and function as a common application in the underlying operating system. Virtual machines can be created using virtual machine manager to share underlying server resources. VMM obtains resources by calling the host operating services to virtualize the CPU, memory, and input-output devices. After a virtual machine is created, VMM usually schedules the virtual machine as a process of the host operating system. The virtualization products that use type 2 hypervisor include VMware Workstation and Virtual PC. So what are the advantages and disadvantages? They are easy to implement. Advantage, disadvantage, only the applications supported by the host operating system can be installed and used. The performance overheads are high in case of type 2 hypervisor. These are type 2 hypervisors. So features of a hypervisor, they provide you partitioning, isolation, encapsulation, and hardware independence features. So partitioning is possible in case whenever you are installing hypervisor and using, it indicates the VMM capability of the allocating server resources. It includes virtual NICs, virtual CPU, virtual memory. You are partitioning everything and it is in this separate place. Whenever we are talking in terms of virtual machine, हमने बात तो कर ली virtual machine, ये virtual machine है, virtual CPU है, virtual NIC. But what does this virtual mean? Virtual है क्या? They are basically a set of files that are on the computer, physical computer. Or when you click on or when you run your physical machine, these virtual machines get active and they behave like other three machines on a single physical machine. In this way, we can say these are the virtual machines. Same way we have virtual NICs, they are set of files. Virtual CPUs, they are another set of files. Virtual memory, these are all set of uh, software files. Resource quota are allocated to each partition to prevent resource overuse by virtualization. Each VM has an independent operating system. So this is all about partitioning. Isolation is possible in case of virtualization. Multiple VMs created in partition are logically isolated from each other. So all the virtual machines are logically isolated from each other. Even if one virtual machine crashes due to an operating system failure or application breakdown or a driver failure, it should not affect the other on the same server. So this is possible in the case of same server. We have different machines. Different machines cannot affect another machine on the same server. So that is called, that concept is called isolation. Next is encapsulation. Each VM is saved as a group of hardware independent files, जो मैं बोल रही थी, including the hardware configuration, BIOS configuration, memory status, disk status, CPU status. You can copy, save and move a virtual machine by copying only a few of files. So जब हम बोल देंगे we want to copy a virtual machine from one server to another, what actually we are doing? We are copying and saving a few files from one machine to another machine. So they are independent. So they are hardware independent, so they can be moved. If they are not hardware independent or isolated, they cannot be moved. So I have discussed about the hardware independence. We can move the things independently. A group of files can be moved from one machine to another. So that is possible, and that is a characteristics of virtualization. So virtualization, when we talk about compute virtualization, from the like we are talking about elastic compute cloud, EC2. This is basically, this includes CPU virtualization, this includes memory virtualization, and input output virtualization. So memory virtualization, whenever we talk about CPU virtualization, CPU will not work individually. It must have some memory to interact with. Also, with the CPU virtualization comes the concept of memory virtualization. So with VMs running on top of the virtual machine manager layer have replaced physical host to run application. Multiple virtual machine can run on the same host. A host usually has one or more memory modules. So how can memory resources be allocated to virtual machines properly? So memory virtualization was introduced to address the issue. So having a virtual machine needs virtual memory also, or any memory also, because if that machine is virtual machine, the memory will be also virtual. So how allocation of that physical memory to a virtual memory is possible? That is also important. So every memory address should start with the physical address 0. This is a concern. The memory address space or the address space that is available physically is allocated to virtual machines continuously. So that is also a concern. However, after virtualization is introduced, the following problem occurs in memory virtualization. There is only one memory address space. हमारे पास तो एक ही memory है ना, physical memory. And virtualized system, we have 3 virtual machines suppose. So how we allocate that memory address space, single address space to 3 virtual machines? There is only one memory address space whose physical address is 0. So physical address of the is 0. Therefore, it is impossible to ensure that memory address space for all virtual machines on the host start from the physical address 0. ये तो possible नहीं है तीनों को virtual machines को 0 से ही start हो जाए क्योंकि there is one single address space and that starts with 0. On the other hand, allocating contiguous physical address to virtual machine lead to low memory utilization and inflexibility. So there should be some mechanism for assigning that virtual memory to the virtual machine. Memory virtualization was introduced to solve the problem of concerning memory sharing and dynamical allocation of memory address. So इस चीज को avoid करने के लिए sharing that common address space starting with zero address, memory virtualization concept came into existence. It is basically centrally managing the physical memory of a physical machine and aggregating the physical memory into a virtualized memory pool available to the virtual machines. So the machine memory management is possible. Memory virtualization creates a new layer of address spaces. There are more layers of address spaces of virtual machines. Virtual machines are made to believe that they run in a real physical address space when in fact their access requests are validated by virtual machine. It appears to the virtual machines that there are separate memory spaces for every machine, but actually there is a single memory available on the physical machine, and they are the translation of address is managed by a virtual machine manager. So we have different types of address like guest machine address space, physical machine address space. So mapping between the guest machine address space to physical machine address space is done by VMM, that is virtual machine manager. Guest machine address space किसको बोल रहे हैं? ये virtual machine की address space and physical machine address space is the machine we are using. So they have shown here that memory virtualization is possible and need 3 addresses translation: virtual memory address, physical memory address, and machine memory address. So the following direct address translation path must be supported that multiple virtual machine can run on a physical host. So virtual memory to physical memory and from physical memory to machine memory. This kind of translation is possible in the virtual memory virtualization. So you can see this is memory virtualization. We have virtual machine memory and this is the host memory. So this host memory address space, that is, suppose it is starting from the 0 and ending with some of the number. So to assigning to this VM1 from 0 to this last address, VM2 to this last address, or VM3 to this last address is not possible. So what they did is they have taken some memory and mapping is done from this virtualized memory to the host memory. Mainstream compute virtualization. We have discussed about the compute virtualization. There are two main ways of compute virtualization. One is open source, other one is closed source virtualization. Open source technologies include KVM and Zen. They are freeware. And closed source virtualization technologies include Microsoft Hyper-V, VMware, vSphere, and Hawaii Fusion Sphere. These closed source virtualization technologies like Microsoft Hyper-V is and VMware, vSphere, and Hawaii FusionWare is used by Huawei company. This Huawei FusionWare and Microsoft Hyper-V. Open source technology are free of charge and can be used anytime. We know this thing. User can customize some special requirement based on open source code. Open source technologies have high requirement on user technologies, but problems occur in the system. The system recovery strongly relies on the administrator's skill set. If there is a problem with the open source technology and it deals with the administrator's skill set and experience. In case of closed source technology, user cannot view or customize source code. So that source code that is provided by Hawaii Fusion Sphere. This is fixed. You cannot customize it or change it according to your choices. And closed source virtualization products are generally not free of charge. We know this thing, and can be used out of the box. If a system problem occurs, vendor provide all-round support for closed source technologies of virtualization. So virtual सॉफ्टवेयर कौन से virtualization सॉफ्टवेयर कौन से हैं? KVM, Zen, Microsoft Hyper-V, VMware, vSphere, Huawei Fusion Sphere. So we have discussed in these slides Zen. हमने Zen को डिटेल में बताया हुआ. It is open source virtualization technology, and it is very much important from the examination point of view. You should know what is Zen. Zen is open source virtualization technology and on par with KVM, while KVM is full virtualization technology. Zen provides both para-virtualization and full virtualization, whereas KVM, a module in the Linux kernel used to virtualize CPUs and memory. It is basically a module in the Linux kernel that provides virtualization concept, virtualization of CPUs and memories. It is a process of the Linux operating system. Other input-output devices need to be virtualized by KMU. What is KMU? KMU कभी किसी ने मुझसे क्लास में नहीं बताया. It is quick emulator. So here in this slide, they have described about the Zen and difference between Zen and KVM. You should study these Zen and KVMs. This is KVM type 2 virtualization solution. इस पे आपको क्वेश्चन आ सकता है, what is KVM? We have in KVM guest mode, user mode, kernel mode. We have discussed these guest, user, and kernel mode in the previous slides, in the previous lectures. Next is this is KVM architecture. This KVM architecture means this is the virtualized architecture. We have guest operating system. On that we have a quick emulator, quick emulator. Next is Linux kernel, libvirt, library virtualized, and these are management tools. Wish, virtual shell, virtual manager, virtual viewer, virtual installation, and others. Now, virtualization cluster feature. What are the various virtualization cluster features? We have discussed in detail about high availability, load balancing, scalability, and memory overcommitment. So, we'll not go into the detail of these things. We'll study in journal high availability. We know what is high availability. A virtualization cluster usually use shared storage, and a VM consists of configuration files and data disks. The data disks are stored on shared storage, and the configuration files are stored on the compute node. If a compute node becomes faulty, the virtualization management system is able to provide or rebuild or the fault virtual machine on the other node based on the recorded virtual machine configuration information. So it never get failed in the cluster. Means if a node fails, other nodes are available and fault recovery is very fast in case of virtualized cluster environment. So that concept is called high availability. During high availability, following issues need to be addressed: detecting host faults, handling VM startup failures. Startup में VM जो fail हो जाती है virtual machine, and how we can handle VM startup failures. VM HA usually used together with application HA to improve the service recovery success rate and efficiency. So VM high availability used with the application VM high availability. If a node in the cluster becomes faulty, you can see if a node becomes faulty, VMs on this node are automatically migrated to alternative hosts that are running properly. So if a node fails here, these VMs can be transferred to the other nodes. Like one can be transferred here or one can be transferred here. So in this way we can transfer the load. Next is load balancing. We know what is load balancing, uh, and how we can distribute the load so that every node get a proper balanced kind of load. Next is advantages of the load balancing. Next is high performance of the is provided when we are doing load balancing in the cloud computing environment. Scalability is there. Load balancing provides a scalability. High reliability is possible if you have balanced the load. Naturally, there will be less faulty nodes, so high reliability of your data is possible. Easy management, transparency. So this is shown in the diagram here for load balancing. Scalability, we know what is scalability, that is also virtualization feature. So you can see here this, and this is a diagram showing that in case of this all in this diagram the load is not balanced, scalable, not properly provided. But in this case, virtualized source pool is grown. You can see the number of resources for used by the various virtual machines has increased. So in this way, a person is the smiley is smiling here, and here it is not smiling just because the scalability is not possible in this architecture, and there were scalable virtual resources available. Memory overcommitment, from the memory overcommitment we mean we have a limited memory, but हमने कमिट ये ज्यादा कर लिया कि हमने कमिट ये कर लिया हम तेरे को भी दे देंगे, उसको भी दे देंगे, इसको भी दे देंगे. To every virtual machine it is a kind of overcommitment that every machine will get a full availability of memory, and that concept is called memory overcommitment. Overcommitment allows virtual machines to use more memory than the total physical memory of the server by leveraging specific technologies to improve virtual machine density. So memory overcommitment includes technology like memory ballooning, memory swapping, and memory sharing. Generally, the three technologies need to be applied together and take effect at the same time, like memory ballooning, swapping, and sharing. Now, what is memory ballooning? The system automatically reclaims the unused memory from a virtual machine and allocate it to the other virtual machine to use. Like suppose anybody in your class is using virtual machine and it is allocated some kind of memory. Later on, but there is another machine on my side, suppose, and that is VM2. And the virtual machine, what virtual machine manager will do, it will reclaim the memory from the VM1 because it is unused and it's lying free there. So that memory will be called or reclaimed and is given to the other person who is using the other virtual machine and need memory. So VMs are not aware of the manner of reclamation and allocation. Virtual machines को नहीं पता कैसे वो reclamation और allocation हो रही है. But they are assigned memory and wherever required we can reclaim the memory. The total amount of the memory used by all virtual machine on a physical server cannot exceed the physical memory of the server. एक physical memory की अगर 8 GB है तो reclaim करके हम उसको 10 GB कर लेंगे. But होगी कितनी, it is between different virtual machine, it will not be more than 8, it will be 8. But just because it appears to two virtual machine they have the same memory block, ऐसे लगेगा VM1 को भी लगेगा मेरे पास है मेमोरी, VM2 को भी लगेगा तो मेरे पास है. जनरली कि VM2 से वो मेमोरी ले ली गई थी वापस reclaim कर ली, and that concept is called memory ballooning. So this is shown by the diagram here. You can see each of the three VMs has 2 GB virtual memory. The memory of usage of VM1 is only 20%. Memory usage of VM2 and VM3 है 70%. जो VM1 है उसकी usage है 20% और VM2 and VM3 they have 70%. The system automatically maps the physical memory allocated to VM1 to VM2 and VM3 in the background to relieve the memory pressures. It automatically does reclaiming, and that is called memory ballooning concept. We know what is memory swapping. जैसे physical hardware पे memory swapping होती है वैसे ही virtualized environment में we can have a memory swapping. So this was all about virtualization in virtualized memory. Now we'll have one poll here. Answer these questions. Kindly answer these questions. Dash allows different operating systems to run their own memory space. VGMs, VMs, VMM, all of the mentioned. Dash U is a CPU emulator and virtual machine monitor. Imaging parallels, KMU, and none of the mentioned. Next is Dash as a service is a cloud computing infrastructure that creates a development environment upon which applications may be built. Next, Dash provides virtual machine, virtual storage, virtual infrastructure, and other hardware assets. All must answer these questions. Kindly answer these questions. So, still students are pending. Kindly answer these questions. I am repeating the questions again. Dash allows different operating systems to run in their own memory space. VGM, VMCs, or VMM, all of them or all of them mentioned. Next is Dash is a CPU emulator and virtual machine monitor. Imaging parallels, KMU, or none of the mentioned. Dash as a service is a cloud computing infrastructure that creates a development environment on which applications may be built. Infrastructure, service, platform, or all of the mentioned. Next is Dash provides virtual machines, virtual storage, virtual infrastructure, and other hardware chipsets. Yeah, SaaS, PaaS, or all of them mentioned. So I'm ending the poll here. First is Dash allows different operating systems in their own memory space. The answer is VMM. Virtual Machine Manager allow different operating systems to run in their own memory space. Next is KMU. Quick Emulator is a CPU emulator and virtual machine monitor. Next is Dash as a service cloud computing platform as a service is a cloud computing infrastructure that creates a development environment upon which applications may be built. Next is ARs provide virtual machine, virtual storage, virtual infrastructure, and other hardware assets. So you can see results here. Next is another quiz. You need to answer these questions also. SaaS supports multiple user and provide a shared data model through Dash model. Next is single tenancy, multiple tenancy, or multiple instance, or all of them mentioned. Dash authentication requires outside use of network security or trust service. Which of the following type of virtualization are also characteristics of cloud computing? The technology used to distribute service request resources referred to as load performing, load scheduling, load balancing, or all of them mentioned. First is SaaS supports multiple users and provides a shared data model through Dash model. Next is Dash authentication required the outside use of network security or trust service. Next, which of the following type of virtualization is also a characteristics of cloud computing? Next is the technology used to distribute service request resources referred to as load performing, load scheduling, or load balancing. Kindly answer these questions. Still, number of students are pending who have not responded yet. So I am ending poll in 40 seconds. All must answer to these questions. Again repeating, SaaS supports multiple users and provide a shared data model through Dash model, whether it's single tenancy, multiple instance, or all of the mentioned model. Dash authentication requires the outsider's use of a network security or trust service. Next, which of the following type of virtualization is also characteristics of cloud computing? Technology used to distribute the service request resources referred to as ending this poll here. First question answer is multi-tenancy. SaaS supports multiple users and provides a shared data model through multi-tenancy model. Next is authentication requires outside user network security or trust service, that is single sign-on authentication is required. Next is which of the following type of virtualization is also characteristics of cloud computing, that is CPU virtualization. Actually, the technology used to distribute service requests to the resources referred to as load balancing. So this was the answer to these questions. Now moving ahead. So I have discussed all other things in detail, but this topic was left. Hmm, sharing the screen here. Network basis of cloud computing. I have discussed these network basis of cloud computing, and we know the virtualization environment in networks. We discussed about NICs, NATs, and with that, we have discussed about bridge-based interconnection in Unix system, MAC learning, and packet forwarding. You need to learn these things, network virtualization, not in detail, just an overview of network virtualization. So next is the storage basics for cloud computing. This involves the storage architecture in virtualization. This is important. Storage architecturing, we have NAS storage, SAN storage, and this virtual volumes, and these things we need to know. This is non-virtualized storage, this is virtualized storage. You should know the difference between them. You need to know about SAN, storage area network, and NAS. What is the difference between NAS and SAN? It may be asked in your session as well in your final paper. Next is this reference model, cloud reference model. We have discussed these things: cloud consumer, cloud provider, cloud worker, auditor, and their role, actors जो हैं the role and scenarios. Consumer, you can see these are the consumer for SaaS, for PaaS, and for IaaS. Cloud provider, role of cloud provider, service deployment, service orchestration. There may be a question, what is service orchestration, or what is service deployment? You should know these terminologies also. Cloud auditor, cloud broker, cloud carrier, scope of control between provider and consumer. Next is SLAs. We have discussed about SLAs, type of any customer based SLA, service based SLA, and multi-level SLA. Life cycle of SLA: template definition, negotiation, provisioning, monitoring, and enforcement, and expiration. And the two types of SLAs, elements of Azure. We have given these are the examples of SLAs. So this was all about virtualization, and I'm coming towards your syllabus. So this was all about part 1 and 2. I have covered this part 1 introduction, and I've discussed till this topic: network virtualization, storage virtualization, hypervisor, and these only topic that left is multi-tenancy and APIs. You need to study these things on your own. And if you have any questions related to any objective type question or any subjective type question, you can ask me on WhatsApp group. So I hope, I wish you all the best. Hanji, is there any query?
प्रीवियस ईयर के क्वेश्चन पर भेज दीजिए.
ऊंची बोलो थोड़ा. Jobin, what are you asking?
मैम प्रीवियस ईयर के क्वेश्चन पेपर भेज दीजिए.
Okay, I'll send you the previous year question papers also, and some of the questions in I can provide you the question bank. कैसे आपको questions आएंगे. ठीक है. Thank you very much.
Okay.